Hello, everyone, and welcome to our Durham Analytics Day. So it's a bit different from what we expected, but here we are. I think it's very nice opportunity on the other side because we can have as many people as possible here without any constraints on room requirements or anything else. So this event will take place now for a couple of hours, and we have a very interesting list of speakers. So just a brief overview of the event. So we started this event over 2 years ago, and this is in collaboration between Durham University Business School and the Operational Research Society. So let me move to the next slide. So you can see here that the OR Society does have an analytics network. So we are partnering with them for this event. And also we have an operational research and data analytics student group within Durham University. And they are also supporting this event. And we'll also give some few words now before we start. And finally, we do have the Center of Innovation and Technology Management, which is a center within the business school, and we are the third partner within this event. So some organizational logistical details for the seminar. Participants are generally muted. If you like to share the video, is fine, but maybe you should mute it. The event is being recorded, and we hope to make it available to the OR Society website later on. And finally, we would use the chat for the interaction, also giving the number of participants, which is almost, I mean, it's 90 now. So it's quite a big number. So please use the chat. How it's gonna work is that we will have presentations for about 20 minutes, and then there will be 5 minutes for question and answer. But feel free to type your questions during the presentation as well, as the presentation goes, and then the speaker will pick up them later after the talk. I mean, welcome from me. I haven't properly introduced myself. My name is Riccardo Mogre, and I'm an associate professor in operations management within Durham University, and specifically within Durham University Business School. So today we will have 3 talks from Eduardo, Frank, and Angela. So that would be very interesting, very exciting topics. You will see them later. And also, we will have a final description about the activity of the analytics network. And this will be done by Matthew Robinson, which I'm already thanking at the beginning for the work he's doing. Great work in the chat, and also with the logistics of the event. So thanks for the great support from him and the OR Society in general. So just a very brief introduction about me, or us more in general, as Durham University Business School. I'm very pleased to say that the Durham University Business School is investing in analytics, both in terms of research and also in terms of teaching. So we do have a research stream on business analytics in the Center of Innovation and Technology Management. And there are 5 or 6 academics who actively do research in this area, and we are recruiting more as well this year. Then in terms of research, we also have a specific group that focusing more on accounting, which is the Durham Rutgers Accounting Analytics Network. This network is a research network in collaboration with Rutgers University in the United States. And then finally, in terms of teaching, we do have a master in business analytics, and this is joint with computer science. So as you can see, we do have 3 different main activities we do for analytics. Besides the business school, there are a lot of other activities that the university does in terms of analytics and data science. In particular, we do have an institute for data science, but this is like the topic of Frank, short presentation. So he will describe more the activities that he does and his institute does later on. Okay, so as I said before, this event is sponsored and supported by our OR and Data Analytics Student Group, which is also a society of the University Student Union. So if Angus is here, maybe wants to say a few words about the group.
Thank you, Ricardo. Okay, so hi, my name is Angus, and I'm the president of the Durham Operational Research and Data Analytics Group. So I'm going to give basically a brief introduction of what we do. So we have two main purposes as a group. We host networking events and we share other career opportunities for students interested in quantitative careers. And we also host events and workshops, teach students more about this exciting and expanding field. So examples of some types of events we've hosted. We've held applications and advice workshops for students interested in quantitative careers. That was last term. And we also hold, for example, talks by data scientists and our workshops to increase students' knowledge and understanding of this sector and the type of skills they need to start a career within it. So if you'd like to find out a bit more about the group and what we do, or interested in future events similar to the previous ones we've held, check out our basic page for more information there. And I'll hand back to Ricardo.
Thank you, Angus. That's great. And I do have another slide, which is Women in Data Science. This is kind of a promotional slide of an event we will have in June, which is going to be a very great event as well. So I'm going to ask maybe Yara or Rowan or both if you want to say a few words about this.
Hi, I don't know if Yara's here, but essentially we're aiming to have the first Women in Data Science event in the Northeast in partnership with Stanford University. We're looking to bring together speakers, and sponsors and some volunteers for a really exciting day. So if you'd be interested in that, contact us. That'll be brilliant. Thank you.
Thanks, Rowan. And yes, definitely. So we will circulate those information about this event later on in the year. Oh, Yara is here as well. Yara, do you want to add anything to what Rowan?
Yes. Sorry, I tried to join earlier. Something happened, some glitch. So yes, we're bringing the Women in Data Science to Durham and Northeast for the first time. The Women in Data Science is an initiative started by Stanford University. It started in 2015. The purpose of this initiative is actually to empower women and to inspire them to join the field of data science and to actually educate participants about the data science and what's happening in the field. So please join us in June. We will be having remarkable speakers sharing their insights and experience of how data science is helping them to push boundaries and advance the field they're working at.
Thanks, Yara, and thanks, Rowan. So we will give more information about this event later on in the year. Okay, so let's go back to today's event. We do have 3 great presentations today. So Eduardo will start with machine learning applications in credit risk. Then Frank will present our Durham Institute for Data Science. And finally, we have Angela, and she's going to talk about building products with good enough decisions. Okay, so I'm going to give a brief bio of the speaker when the presentation starts. So maybe I'll stop sharing right now, and I'll ask Eduardo if he can share the presentation while I give him an introduction.
Thank you. Yeah, we'll do.
So Eduardo has been great for Durham especially. So it's a couple of years that we have met, and he also helped me to organize the first Durham Analytics Day. And since then, we've been involved in various activities as well. So it's a great pleasure to have him here again to present. Okay, it's brief bio. So Eduardo Contreras is currently a principal consultant at Foremost, and he specializes in developing machine learning credit risk models. So before Foremost, he was previously worked in companies like Ernst & Young, Lloyds Banking Group, and Citigroup, and he was developing analytics solutions and risk modeling. And he's also the chair of the Analytics Network, which is part of the OR Society. So the floor is yours, Eduardo. Thanks for presenting today.
Thank you. Welcome to my talk of machine learning applications in credit risk. Before I start, I want to make a little bit of a survey to get to know your experience of machine learning. So if we can go into the chat, and can you please type if you don't have any relevant experience in machine learning, if you have some relevant experience, or if you are an expert on machine learning. Will be really good to know what is your experience, so I can also tailor a little bit the content and probably skip some parts that are, or try not to get into a much detail in some of them. So yeah, let's see your answers. So yeah, just please type into the chat. I have seen no relevant experience, some. So yeah, none, some doing neural networks. Okay, none. Okay, so it's I'm gonna be seems that it's a lot of people with some or just really non-experience at all. So I will try to go into a really try to avoid the really specific details and try to make it really accessible for everyone. Thanks so much. So yeah, so let's start with the presentation. So first of all, I'm part of Foremost that is now more than in a company that is with more than 10 years partnering with clients, especially with banks. And we are the largest UK risk consultancy now with 130 permanent consultants. And in this presentation, I want to cover 4 topics. The first of it, I'm gonna doing an overview of why to use machine learning, and also covering briefly what is machine learning for all of the people that are not that really familiar on this. Then the second point is going to be how it is currently used machine learning in financial services and in credit risk here in the UK. And then I will be covering the part of the impact. What is the impact that COVID has had in machine learning in financial services? And finally, I will be covering how do we do machine learning? How do we use machine learning in Foremost and the applications that we have done with our clients? So let's start. So first of all, with machine learning, well, for those ones that are not familiar with this, it's basically machine learning is a part of artificial intelligence and also part of computer science that is there are algorithms that allow us to analyze really big data sets and also to identify really complex patterns in data. And I think everyone is in somewhere aware that machine learning is now everywhere. So we can see that in our emails, trying to detect if an email is a spam or not. Also now we hear a lot in the news about self-driver cars. So basically everything behind detecting how to make a car to drive by itself is part of machine learning. It's done by machine learning in some ways. And also even just every time that you go to your Netflix or to your Spotify, the recommendations and suggestions, they are done by machine learning. And obviously, it was just about to happen that machine learning it's now in financial services and in specific in credit risk. And let me give you a really quick example of how it's done. So probably you are familiar of credit scores. A credit score is a score that every time that you're going to request a loan, a mortgage, overdraft, or a credit card, the banks use the credit scores that they are built using a lot of data from how you have done your purchases, how you have done your payments, how you have all of the information across other banks. So all of this data is summarized in one number, and that's the credit score, which means how good you are in paying loans or debts. So back in the day, really long time ago, all of these scores were mainly done by the business writing like the decisions, like really, really basic decisions. There was no data used before. It was just their business knowledge. But eventually now, with around 3 decades, there has been a lot of developments in computing that we started using the credit scores. We started to use statistical approaches. And by this, I mean statistics regression, logistic regression. So it was techniques that were quite easy to use. And they were absorbing all of the data. And then they were used to create these probability models and these scores at the end. So it has been now like 3 decades that we have been using that credit scores. But now, recently, with machine learning, now that with more powerful algorithms, we are now using them because there is more data available. We have more computing power, and also with all of this complexity, these algorithms are able to find really complex patterns that before with logistic regression or any simple regression we couldn't have found. So this is about machine learning. It's giving us more power to have more predictive models, and eventually the business to benefit from there to make more accurate decisions, or who are they gonna lend the car, or who are gonna give a mortgage or a credit card. It's all about making sure that they take better decisions on risk. And now with this overview of how is used machine learning, let me give you a quick example of in general of how is the financial services industry in the UK, how they are using machine learning. And this is a quick overview of how from the Bank of England, they did a survey like in end of 2019, and they found that machine learning is already there. Like 2/3 of the financial services of the firm, they are using right now machine learning. And especially in banking is the ones that they have been using it the most. And this is, I think, is mostly for the legacy that credit risk has built with using these scores for a long time, but also in detecting fraud. Fraud has been all of the part of detecting if a transaction will be fraudulent or not. It's also part of, has been quite a long time done by machine learning. So I think that's why the banking is one of the sectors that has been highly used machine learning. And in terms of the areas, probably it's going to be interesting for currently the people that are studying their MBA or analytics. Probably they can see here one of the areas that they could be interested to join. And especially in risk management is one of the sectors of financial services that they are using a lot of machine learning. It changes, it varies a lot. Customer engagement is also using it a lot, credit risk. And insurance is catching up. Right now, insurance is not heavily involved into use algorithms in machine learning, but everyone is starting to pick up and starting to deploy models using machine learning. And what about the techniques? I think it's also important that there are so many techniques in machine learning. There are, as I was mentioning before, for example, to make a car to drive by itself, it uses different algorithms of machine learning. It using all of these image recognition and algorithms. While, for example, in the case of financial services and in the case of credit risk, we use other types of algorithms. And in this case, for example, one of the most used across the financial services is the tree-based models and natural language processing. So in general, these models are generally to identify if someone is going to pay or not, if they're going to create fraud or not. So it's a different type of techniques that other industries are using. So what is good to know how is in general the different techniques that they are using. So how's the impact? Now that we know how is in general machine learning using in financial services, now with last year pandemic, what was the changes that we experienced on using machine learning? First of all, it's really impressive that now banks from Bank of England did just a survey just at the end of 2020, that they found that machine learning and data science are becoming more important. And I think it comes because banks also realize that that they need to automate many parts that potentially were done by humans, and in some way humans now are susceptible, in this case, from the pandemic, and probably some of the workforce could be sick and they couldn't do any kind of activities. So machine learning and data science can help automate many applications, many processes, and this is something that I'm going to cover in one of the examples of the applications in further slides. But yeah, I think it's a really good opportunity for machine learning, since it seems as more relevant as before the pandemic. And they are planning even to invest more in it. So, and one of the things that also it seems that the areas, different areas are thinking to invest more, like for example, the customer and client engagement, they are thinking to invest more. And I think you have seen more and more recently, for example, any app or any bank now, they are using Autobots. Like every time that you try to contact customer service, probably you are starting now to be in contact directly with a machine learning algorithm to start first address your questions that you have, and then later on they will after you have been in contact with them initially, then they will pass you to a real human. So that's why I feel now they have a really strong impact, and different areas that are trying to use it more, but it also depends what parts of their business they try to optimize or automate. And now that we know in general how it works in machine learning, I want to give you an overview of how we do machine learning in Foremost, as I'm one of the main developers in this area and researchers on this area at Foremost. And we follow principles in machine learning because we have heard a lot in the news about that potentially probably machine learning is quite a black box and no one knows how it works, or that is so complex that no one understands how it works. So that's why we have applied some principles now in how we use machine learning in Foremost. The first of all is we need to know what is useful for our case in credit risk and financial services. As I was mentioning before, there are so many types of machine learning methods that not all of them will be relevant for the part of building credit risk models. So we need to keep on track of what are the latest developments, and that's something that, for me, in my case, I'm really excited to keep track of this. And one of the things is that we need to make it really easy to understand, transparent and auditable, because at the end, our models are affecting people. So every time that someone goes to get a loan, and potentially, let's say they are denied to receive a loan, they have the right to ask what was the reason that they got denied the loan. So the machine learning models needs to show what was the reason that took that decision, and that part of it is to select and to adopt the right models. So for us to make sure that we understand how the model works and how we can explain the decision to the clients, and also for regulatory purposes, because all the banks that are using machine learning, in some way, they need to comply that they know how their models are working, because it's part of building trust with their customers and with financial authorities. Also, as I was mentioning before, there are so many models of types of machine learning. Some of them are quite basic, like let's say even a logistic regression or a simple linear regression is a specific type of machine learning. But then the machine learning are evolving into more and more complex techniques, and some of them even require supercomputers just to run. So it's a lot of models down there. But we try to cover the most of the different techniques, but also making sure that we are using the appropriate one. Because at the end, the banks, they need to use it, and they need to use it with their computing resources, and many of the applications are live and they need to make a decision straightforward. In the case of Foremost, we have developed a tool, a proprietary tool that has a front end on a web-based front end. And this tool, we have used it to validate and to explore the models visually. And this is something that I'm going to be covering also in the next slide. This is more to automate also our analysis to make sure that we can produce models in a more confident way, and also without that much coding from the developer, and also for our clients to analyze how the model works. So this is I think at the end of it, with data visualizations, we can make sure that everyone knows how that model works. And I think this is a really good, important part of our process of developing models with machine learning. And finally, since all of these models, they need to be run, they need to be implemented, we also need to make sure that the models that we are producing they are straightforward to implement, and also that our clients can implement them in their own resources. So that's something that we have. These are the principles that we follow every time that we do a model with machine learning. And I'm going to give you an overview now of how a model of machine learning is done. And in this case, the first of it is data. And I think this is one of the most important parts of it, because we need to make sure that the data is the data that goes into the model is correct, that we are using we are not using irrelevant data, and also that all of the data transformation, all the summarization of data, it makes sense also to the business before everything goes into the machine learning model. So this is a crucial part, and that involves basically a lot of merging databases, making sure that what we are putting all together is similar results as the bank or our clients they use in their everyday. So that's an important part to verify that our models are, or the data that goes into the models are appropriate for it. And of course, the model development, and probably some of the people that are from the computer science background, they will be more familiar with it. It's about creating the database to summarize it in a level that then the machine learning model, they can start to analyze where is the patterns, and in this case, for example, on a credit score, what are the patterns that make, for example, a customer to be late in their payments. It could be probably that he has been using a lot their credit cards. It could be also that he or she didn't miss a payment like 3 or 4 months ago, or even could be that they got recently a mortgage. So the models will start to analyze all of these different patterns and start to see which ones are the most relevant that make a customer better borrower or not. And then at the end, all of this be transformed into a probability model. So all of this, it's done in this model development. And once we have the model development, then the next thing is how this machine learning model can be used by the business. And this goes all the part that making sure that the business understands how the inner workings of the model works. And also, once they have this score, how they can use this score in their strategy. For example, it could be that the client, or sorry, the banks can just lend to a specific profile of risk, let's say really high affordable customers. So they can use this score to tune in their strategy and say, for example, okay, from people that have a score above 800, then we're gonna lend. Otherwise, we're gonna have a review of their lending criteria. So this is about making the strategy, and we support our clients to work with this strategy. And finally, once the models, they are live, one important thing is that also we need to make sure and check them regularly that they are accurate. Because let's say, once we have, if we develop a model right now with data before COVID, then potentially there are many shifts in the data that has made the model less accurate. So we need to check if the model is still working with this data with COVID. Otherwise, we need to adjust the model, or potentially to develop a new model now using the latest data. So this is the way that we manage and develop models, and also the way that we can track and make sure that the models are still fit for purpose. And at the end is to make sure that the business and the banks, in this case, they are using the right models and applying the right decisions. So now I'm going to cover, if you are more interested into this tool that I was mentioning, you can go to the website that we have especially for this tool, and then you will see how everything works. And I think what I like from the tool, and use it, and as I use it as a developer, is that it facilitates a lot of the data visualization explorations that are really important for the understanding of the model. So I'm going to cover an example that we did with for credit underwriting, and this is going to show how the business can automate many of their processes. And in this case, it was to decide who will be approved to receive a loan. And this is because, let's say in this case, the current process that they have is that they have around 100,000 applications per year for customer. They have a lot of data, all of the customers that they were asking and going to their websites to request a loan. So the business, what they were using is they're using the underwriting guidelines, they were using their processes, and in some way verifying manually many of these cases, and following, checking, for example, age, checking the income of the person, checking also how many years they have lived in their current address, if they have any other debts with other banks. So all of these they were checking in some way manually. So that makes a lot of time that is spent by manually by the underwriters, and it's a lot of time that can be automated because many of the decisions can be just straightforward. For example, if the customer has already committed fraud recently, then that's a no for the bank. They need to be rejected. But there are cases that they will be really easy also to detect that they are a really good customer, and then they need to go to the next stage of the loan. So then this model, what they were looking for it is to make sure that they're having a process that they will say, okay, we're going to approve this loan, we're going to decline this loan, or we're going to request more information because probably they missed something in their application. So with this machine learning model, that we did, we put all of this data all together and consolidated, ready for the model, making sure that everything was making sense for the business. We found the patterns that are behind all of these processes that they were doing manually. So the machine learning model found what makes like a better customer, and in this case, developed this model and removed many of the parts that could be automated because there were other parts that they needed additional review for the underwriters, and because there were special cases of customers. And at the end, what the bank had, it has a smoother process with it was saving a lot of time for the underwriters to check all the processes and all the loan applications, and eventually just the underwriters at the end, they just focus in what is important, the important cases, those special cases that they need to have the attention for. Conscious of time, I'm gonna be the benefits of this model at the end. It was, as I was mentioning, it was a smoother process. They managed to enhance all the strategy that they were having with these processes. Obviously, if they don't need that many people working just doing all of the loans applications, they save some money on efficient, make more efficient this process. And it was also more flexible because they can also at the end use their spare resources for other analysis or processes. We have, and it's not just this model that we have done. It can be applied in many types of portfolios. For example, just in personal loans, in credit cards, in mortgages, and also in asset finance. So machine learning models can be applied in many different scenarios. When people go to apply for a loan, or when they are existing customers, when you receive a special increase of your credit card, or basically also to check if they are committing fraud or not. So there are so many applications that these machine learning models can be used. And yeah, this is all for me. So hope you enjoy the presentation, and now we're gonna go through to some questions.
Yes. So thanks, Eduardo. It was a very interesting presentation. Just a very quick comment. I think we always focus a lot on the algorithms themselves. So it's good that you presented the modeling framework. So we know what to do when we apply the algorithm. We know where we go with the process. So I think that was very, very nice and innovative. There are a couple of questions in the chat. which are quite interesting on transparency and bias. So maybe you could quickly address those.
Yeah, in terms of the transparency, that's something that we have focused a lot. Is because there are many machine learning type of models that they don't allow that much to investigate how the model is doing the decisions. And in this case, for example, in the spam or in computer science, many of the decisions they don't really need to know what was the driver of that decision. Let's say, for example, in a spam, detecting the spam or not. As long as the decision looks fine, it's okay to use. Or in our case, we need to know why, for example, the customer doesn't get approved with a loan. We need to let's say analyze and break down all the model decisions. And one of the techniques that we have used quite a lot is gradient boosting trees. And there are many types of these techniques. But what they offer is they can analyze and you can break down the probability into what were the effects that at the end pushes all that probability, final probability. And in terms of biases, we are working, we are making sure that when we are putting the data into the model, that the appropriate data is there. So we, for example, to avoid variables that can discriminate, that can create discrimination, so they are excluded automatically before any type of modeling, just to make sure that at the end we are using the right data. Yeah. And let's see, any other questions? I've seen other questions about transparency and bias. Yeah, I mentioned that one. Oh yeah, in software, yeah, that's a really question. In software, we use, as we are consultancy, we use all of them. We use R, SAS, mainly all of our framework and tools are that I was mentioning in R and SAS. But we have, once the models they are developed, then we port them quite straightforward into Python, which is also getting more and more used with our clients, especially all of these new fintech banks, challenger banks. They're already everyone kind of into more new platforms as they are new banks. And while all the big banks, they have a little bit more older legacy banks, they keep using software that has been used along in the industry, like SAS, for example. And I think also one thing that I forgot to mention, like if anyone is interested to know more about Foremost, we have positions available. If you head to our website, then you can there are graduate positions, consultant positions, and many ones that if you are interested to join the credit risk. And it's not just machine learning, but any type of credit risk, and that is related stress testing, forecast, economic forecast. So we have a lot of in there.
Eduardo, I think there is also a follow-up question from Tracy about fraud and integrity of the systems. Maybe if you could quickly address that.
One of the fraud one, like I think this question goes into if in some way how we recalibrate the models. I feel it is the question. So normally many industries, what they are using is they update the models automatically. Once it comes new data, then just basically the machine learning model automates the update of the refresh the model. In our case, it's not as that, because the bank needs to make sure that the model is fit for purpose first, and then also needs to have a lot of approvals to make sure before it goes into live systems, and it also requires a lot of testing. So normally for banks, and especially in credit risk, they don't have automated recalibration systems, because they need first to go through a lot of compliance before being live.
Thanks, Eduardo. So in the interest of time, I suggest that if you have further questions for Eduardo, you can take them offline with him, and so we can move to the next speaker. So the next speaker is, thanks, Eduardo. So the next speaker is Frank Kraus. So welcome, Frank. Is a professor and director of the Institute of Data Science at Durham University. Is the founding director. I think he created the institute pretty much single-handedly at the beginning. So I'm gonna read a short biography for you, Frank. So Frank works in particle physics phenomenology at the Institute for Particle Physics Phenomenology, which is a branch of theoretical physics, and that bridges the gap between theorists and experimenters that search for and measure phenomena like the Large Hadron Collider at CERN, where he was also a postdoc. As I mentioned before, he was the founding director of the Institute of Data Science and is going to describe some of the activities that they have been busy doing in this year. Okay. To you, Frank, the audience is yours.
Hello. I hope you can hear me. Thank you very much for this kind introduction and for the opportunity you give me to present the Data Science Institute. As I was introduced as a particle physicist, I should stress that, yeah, indeed, I'm a particle theorist, and my background is mainly in simulations for the LHC. Now, I'll talk a little bit about our little outfit, and that is the outline of the talk. So I will talk a little bit about what our mission is. I will start off what we actually do with a couple of highlights from various student placements, and while I talk, I think it will become clear why I do that. And then I will talk about two examples of ongoing research that, for various reasons, are dear to my heart. Okay, so before I start off, let me just entertain you with some general thoughts about data science. And probably I'm carrying cold to Newcastle, but I think it's quite important to every now and then to go back and understand what we're actually talking about. So for this data science, there is by far and large, there's two views on that. And one view is relatively, let me phrase it, focused on the machine learning AI part of it. And that is perfectly fine. But in my view, maybe data science is a little bit wider, and it starts with how we actually acquire data, either by collecting them or by generating them. So we either take data from let me call it, physical systems in the sense of stuff around us, or synthetic data, where we use simulations. We have to process the data, and that is a first step, let me call it data acquisition, and then we have to store data and we have to manage it, pretty much because if you can't find your data, you don't have it, right? So it's better to know what you do in terms of, let me call it, libraries and indexing. Then comes what you would call core data science machine learning, which is to some degree at the interface between statistics, machine learning, pattern recognition, how you visualize your data. And finally, you go to the interpretation of data in terms of models. You maybe make predictions, you maybe make decisions based on your analysis. And depending on how lucky you were, you start realizing very quickly that your model actually was not half as good as you hoped to. And you go back to the first step and the cycle starts again. Now, the one thing that I would like to stress, although I won't touch on it much later on, is there's a lot of questions along the way, and they range from how to do stuff theoretically, how to do it in practice, what are the ethical and what are the legal consequences and implications of what we do. And our institute tries to find answers along these lines. So the mission is that we try to foster exciting, high-quality interdisciplinary research. So when we started, it was pretty clear that Durham had some strengths, but they were quite fractured in different departments, in different faculties, and quite often colleagues sitting in different buildings didn't know of each other. And it all came to pass when we wrote an application for a large doctoral training center in data science, which was pretty much dead on arrival, because we didn't have any structure that was seen by the panel to be capable of underpinning all our individual strengths. So we were lacking structure, basically, and that was the starting point of my partner in crime, Carlton Boy, and myself, to go through departments and to badger and bully is maybe a strong word, but to convince people as forcefully as possible that we need to have such a data science institute. The idea of this is that we try to apply and to some degree develop cutting-edge methods for the analysis of data. And with our background in physics that both of us had at that point, we thought it's it's the 4 big V's: volume, velocity, variety, and veracity of the data that you have to deal with. And ultimately, we want to provide a central hub for establishing old and building new connections with people in the region and beyond. So that was pretty much the logic of why we wanted to form this institute. And when you look at the structure in Durham, you start realizing very quickly that we have 4 somehow quite often little bit 4 faculties that feel a little bit disjoint, and there's not much cross-cutting stuff necessarily going on. So we decided that the best way of trying to organize ourselves was not along the, let me call it, more traditional limits of faculties, but more along topics like, for instance, language, how you deal with, say, natural language processing, what you can do there in various fields. In terms of images, image recognition, either of the cultural or the societal or physical sphere, doing numerics or discussing cultural implications of what we do. And based on this structure, we constructed a management board where I have 6 co-directors: Carlton Bohr from physics, Danny Donoghue from geography, Jochen Einbeck from maths, Peter Heslin from classics, Sally Street from anthropology, and Claire Warwick from English. Now, the starting point for all this was that the other physicists in this management board and myself, we were successful in applying for a doctoral training center in data intensive science. And so we already had a doctoral training center, and we've just failed with the follow-up application. So what is this doctoral training center? It's funded by one of the research councils of the UK, STFC. So a little bit of a tired joke, but STFC is not Swindon Town Football Club. It's the Science and Technology at Large Facilities Council, and it's pretty much astronomy, nuclear and particle physics. And we built on our 2 pretty good groups in physics and astronomy and particle physics. We have to date, we have 3 cohorts with in total 25 students. And what you see on the right-hand side is a photo of the first cohort of students. Our PhDs are funded for 4 years, which is a little bit unusual for STFC because typically it's only 3.5 years. But the condition is that they have a mandatory non-academic sector placement of at least 6 months. So in the following, I would like to talk a little bit about these placements because, to be honest, a lot of very exciting stuff came out of it. So let me talk about a first placement some of our students did with a local SME called IBEX. It's an X-ray imaging company who tries to, who develops software and solutions for improved X-ray imaging. Our students that we placed there actually worked on training neural networks to distinguish the soft tissue and bone. So pretty much when you think about an X-ray and you want to check whether your bone is broken, there's this fuzzy gray zone between your soft tissue, your flesh, and the bone, and this fuzzy region kind of makes some of the fractures pretty opaque to see. So in order to support the identification of broken bones, one of the first things you have to do is you have to distinguish soft tissue and bone, because then you can look for cracks in the latter. Now, what you see below is the result of some of the post processing of the data that they did. It turned out, by the way, just as a little anecdote, they were running out of training data very quickly, so they had to go to a local butcher's shop, to slaughterhouse, and buy animal carcasses, more or less. Anyway, they trained their neural networks, and the results of this project is now part of IBEX's product. So they actually improved the product of this company. They also taught Python and how to do machine learning and neural networks to people in the company. And the outcomes of this placement: publications, an invitation to the largest global X-ray imaging conference, where they won the prize for the best poster. So I think that was quite a success. We had another placement with United Nations Global Pulse. One of our students worked in New York for 6 months among and he mainly worked on two things. One was to identify structures in refugee camps in Jordan and Syria, and you see it on the right. So there's pretty large refugee camps where people live in tents and shelters. And one of the big problems there is you see the satellite photos, and then you have to identify which tents are actually kitchen tents or for toilets or God knows what, and which tents are actually for residents. And in order to monitor that, you have to annotate the tents to have any idea how large the camp is. And typically this was done by hand by some analysts in United Nations. And they now replaced it with some artificial intelligence that actually goes through this within 10 minutes or so and annotates a huge camp with tens of thousands of tents. Another piece of work the student did there was some investigation on how to produce fake news based on natural language processing. And in fact, this placement was quite successful and led to an ongoing contact with the United Nations, which we capitalized later on now during the COVID crisis. Just finished was, we had two students who did a placement with a Dutch finance company, Optiver. And the topic there was to apply deep learning methods for performance improvement of trading strategies. And if you look at the plots, they're a little bit small, and maybe I should not show them. What you see in the kind of greenish blue is the benchmark of profit over time, and in all the other colors you see the improvement that you can gain from deep learning. So there's certain strategies from the deep learning methods that improve the profits by a visible fraction. And the last placement I would like to talk about very briefly is of some of our students who currently works for EDF, which is an energy supplier. The work is on predictive maintenance for the nuclear power plant around the corner in Hartlepool. The goal is to identify early markers of potential issues. Let me very colloquially say, if valves wobble, you have to replace them. Now the problem is with nuclear power plants, you have to stop running the reaction, and every day the reaction and the reactor is not running, EDF loses about £1 million. So their interest is to reduce these unscheduled downtimes to replace or repair stuff during the scheduled downtimes. And that is pretty much what the topic for the student is. Relatively successful. So there's a time series analysis of various parts of the reactor, and they got condensed into a dashboard that provides decision support for engineering staff. So these are the kind of student placements that our students did. We had about a dozen more, and let me just say, I think there was not a single placement where the students didn't over deliver way beyond what the companies wanted to see. So that is, I think that helped us a lot in creating a base of local contacts. Having said that, I would like to move very quickly now to a little bit of ongoing research. And the first thing I would like to very briefly touch upon is some of the remote sensing activities. And this is some interdisciplinary collaboration between physics and geography. From the physics, we have someone who works on calibrating large telescopes with UAVs, with drones. And from geography come some ideas about plant pathogens. And the first example for that is coffee. Now, coffee is something that is traded globally, and it's actually quite a big market. And in Thailand, there's a region where for 30 years now coffee has been planted. But the people there have two problems. The first thing is they started planting coffee, as I've said, 30 years ago, after the king decreed that opium plantations are not so optimal. So they planted whatever they could get, and that is not good enough because you have to know what kind of coffee you have, and there's different types like Arabica or Robusta or Geisha or so. and they differ in the color of their greens, of their leaves. And but there's also quite an evil pathogen there called coffee rust, which makes your leaves look, as the name suggests, rusty. So what you see below is a healthy green leaf and a rusty leaf. And what you see with the faint red lines are the reflectance spectra. That is the light that gets reflected by the leaves for different wavelengths. And you see it's very different. There's a peak in the green region, that is in the green-yellow region, that is very differently high. And the idea is to use machine learning to identify a handful of best wavelengths for bespoke camera that you can mount on UAVs. The background for that is that to do some spectroscopic images, you need a very expensive camera. But if you manage to identify just a handful of wavelengths, you can build bespoke cameras pretty much out of mobile cameras with a few filters. And the idea is to try to identify something that helps to build this bespoke apparatus. Similar topic, similar logic, slightly different topic is to look at mangroves. And what you see on the top right is, again, some of these reflectance spectra. And mangroves come in 3 different types, which I didn't know, 3 different species, black, red, and white. And the reflectance spectra pretty much overlap. Now, if you want to make sure that your coastal areas are, especially in the tropics, are relatively safe, you want to have mangroves there. They contribute to the stability of the coastal line, and also they absorb CO2, so they're quite important. But unfortunately, these 3 different species have very different resilience to climate change. So it's important to monitor and, if necessary and possible, intervene in what happens. But unfortunately, the reflectance spectra are not discriminating enough. So at the moment, we check in how far we can add shape information about the shape of the tree from LiDAR data to have to produce a monitoring tool. So that brings me to the last topic I want to talk about a little bit longer, because I think it's quite topical, and this is something I was involved in. So by definition, this must be cool, right? So anyway, I would like to talk about something that we built in the last year, and it's a simulation of epidemiology. Let me just say, I mean, it's clear no one I work with on that topic is an epidemiologist. Most of us are physicists. There's a mathematician there, someone from the business school. So quite a different skill set. The project started as a simple hobby project where I try to explain to my kids how a pandemic works, but it got taken up by our CDT students. And by now we spent, I think, between 3 and 5 people years on the development of that code. What it does is that it traces the 55 or so million residents of England and Wales on a day-by-day basis. So pretty much, let me put it like that, we know where you live and we know what you do. We trace people, we trace their contacts in the community, and we put this all into a large computing framework. Roughly speaking, 1 year for 55 million people takes us 1 day to simulate. Lots of what we do is based on public data, either for the population, where we use the Office of National Statistics, census data, a little bit of Statista, and disease progression, where we use, again, Office of National Statistics, Public Health England, and others. It's used by NHS England for their operational planning, and it also drives the collaboration between Durham, the United Nations, the WHO, and the MIT IBM AI Watson lab to provide insights for the response in refugee camps, which were pretty much the management of these refugee camps is panicky about the impact of the disease on their population. So what we do in this code is we harvest the census data, and for those of you who don't know the census data, it's highly hierarchical. So you go from England and Wales down to regions, from there to local authorities, so regions like the Northeast, for example, and you drill down until you arrive at something that is called an output area, which on average has 250 people with similar socioeconomic characteristics. And just for reference, the Northeast has 26,000 of these output areas. Now in the blow-up, you see Durham, the output areas. And for those of you who know Durham, the big green zone with nearly 4,000 inhabitants, that is actually the Hill colleges, okay? And you see it in the population, it's pretty much equal between male and female, and the average age is around 20, 22. So that's our students. But then when we built this, we looked at another area in Durham, pretty much in the center of town, and you see lots of men in there, not so many females. You see we have a couple of students again, but we also have lots of men, and funnily enough, they were all living in a big household. So we were kind of wondering what it was. And for those of you who live in Durham, maybe you know, it's a prison. So we found, by doing this, we found prisons, army barracks, you can imagine. We know where people live, and we know their age, we know their sex, we know their ethnicity, we know the household size and composition they live in, and that is very important. So we put it all together with a lot of secondary data, like the age difference between partners, and that allows us to build realistic households. We have the geolocations of schools, we know the age range, we know the number of students, so we distribute students and teachers. We have a slightly outdated but relatively clear picture about companies and the workforce in 21 sectors. So we pretty much know where people live and where they work and in which sector. We have to fix the correlations between these, but in principle, yeah, we kind of know. We know the commute patterns, private versus public, and we have quite a good idea about activity patterns. So what you see in the top plot is the student-teacher ratio in different schools, and you see we kind of get, it's not perfect, we get it kind of right. In our secondary schools, our average for the student-teacher ratio differs by 1 from what the Department for Education gives us. And in the lower panel, you see what the Office of National Statistics thinks about where people spend their time in their residence, at work, and so on and so forth. Now, once we had all this, we now applied it with, we now supplement it with what happens once people are infected. And let me just say, to extract the data, to extract the information was probably the worst data mining exercise I've ever seen. So the data coming out of what impact COVID had in terms of infection rates, hospitalization rates, fatality rates, the data quite incomplete, quite often inconsistent, different notations, pretty massive data analysis exercise where we had to do a lot of inference. And what made things worse was that, in contrast to pretty much every other simulation, we tried to treat the care home population different from people at home, pretty much because in the first wave, the care home population carried a lot of the fatality rates, and we thought we better get that right. And that made life extremely unpleasant and complicated. So anyway, what you see in the bottom plot is what we got out of this exercise in terms of outcomes or worst outcomes of infection. So the blue is asymptomatic. The orange is that people have maximally mild symptoms. Green is severe symptoms. Think of something like pneumonia or so, and it goes up to people dying, either in the hospital or at home. We have similar distributions also for the care home population, and they look much, much worse, so I didn't want to show them. So anyway, we put it all together, and we distilled results for the daily deaths in hospitals in the regions of England. The bottom right is England total, and the other 7 are the 7 regions of England. In the top row, the east of England, London, Midlands, Northeast. In the bottom row, Northwest, Southeast, and Southwest. And you see, it's okay agreement with data. We improved it ever since. But that was the status of the play we had about 8 months ago. So this is what at that point we knew. And then we made a prediction. So end of August, we run our code and we check what happens when schools get opened. And what you see is in blue, this is our prediction for the deaths in all of England. Black is the data, blue was the fit from the first wave, and orange was the prediction we made beginning of September. We showed this to NHS England and people started to panic, and it turned out they were right to panic. So now this is pretty much run of the mill. Let me show you something that I think no other code can really do. So we looked at cumulative infection rates until July 2020, and we looked for various different markers, for instance, household size or ethnicity. And please keep in mind that we distributed people into their jobs and households, etc., according to their output area. So there's no bias in assignment. We did not put any kind of genetic marker that ethnicity A is easier infected than ethnicity B. So what you see here is just the sad impact of circumstances of life on your chance to be infected and potentially die. And what you see is not a big surprise, really, that the larger the household you live in, the higher the probability of you getting an infection. And you see comparison of our June simulation with data from seroprevalence data. But we also have this, and that is the lower plot against ethnicity, and we could even distribute it over the 20 ethnicities in the census data. So we actually see that the infection rates of certain ethnicities are up to 3.5 times higher than the white majority population. And that is in marked contrast to what some of our politicians want us to believe. So a lot of the misery we see is completely driven by the socioeconomics of how people live. Okay, so after this, let me very briefly go to what I think is the future and the evolution of what we do. So there's a couple of things we want to build on. So it's pretty clear this the pathogen identification in plants remote sensing will be something very exciting for various purposes. The one thing we can do is precision agriculture, and at the moment we look for coffee and mangroves, but we have ongoing projects to look for wheat and other crops, for oak and other trees that are relevant either to feed the population or for building. There's also a big impact of what we can do in terms of helping organizations like the World Wildlife Fund for nature preservation and to mitigate to some degree the impact of climate change by trying to grow the right plants in different regions. And we want to use this to construct bespoke instruments to help people. We have a couple of ongoing projects in medical imaging and medical data in collaboration with various NHS trusts. And very recently, we started to get interested in space situational awareness, which is a nice word of asking, how do we make sure that satellites don't crash into each other or into the junk that came from previous collisions? So it's space junk and how to deal with it, which is going to become a very interesting topic for the next 20 years. For the simulation, we want to continue our construction of this digital twin of the UK population. And of course, it's quite straightforward to add Scotland and Northern Ireland, to extend our code to other infectious diseases, to different strains of COVID. That's all work in progress. The one thing we want to do is to also make projections of health demands in the future. And to do that it will become necessary to add the dynamics of the population into our code, which is aging, natural birth, and death, not from infectious disease, but just as a fact of life. So that would pretty much promote our code to go beyond the relatively static picture given by the census data. And we actually want to investigate other extensions of the code that we have not fully touched upon. For instance, including critical infrastructure, think about electricity and other provisions, traffic, like including major roadways, railways, and the more consistent use of mobility data or pollution. So we want to build on that to have a digital playground to check for the impact of certain developments. Now, let me just say that I think we made in the last 1.5 to 2 years, we made some first successful steps towards establishing IDAs in the Durham ecosystem. We have a running weekly seminar program. We have the first joint research projects that start leading to publications. The first funding applications went in. Many of them were shut down. Some are still ongoing, and some may even produce some funding. There's a couple of lessons for me personally to learn, and I think that are relevant to reflect upon. Whenever you start something, whatever you think, it will take longer. And the reason for that is just, you know, systems are large and they are kind of, you know, it's very hard to move things sometimes. And at a place like a universities sometimes feel like a super tanker that you try to deflect by rowing a dinghy around them, which is not necessarily the most healthiest option. The other thing that I think is important to realize is data science is completely driven by high quality data. If you don't have the data, you have nothing, seriously. And this is something that we learned pretty much in everything I talked about. Whenever we had data that were not up to scratch, our models and simulations failed. So that means we want to position ourselves in the long run in the interplay of data acquisition, simulation, high performance computing, and decision support. And that means that we have to probably improve how we communicate with each other. And yeah, I think that is a fitting last slide. Thank you very much.
Thanks, Frank. So it was an excellent presentation and a very, very commendable project that you're doing currently. In the interest of time, since we are running a little bit late, I suggest that if you could, there are a couple of questions in the chat that I've seen. So maybe if you could take those offline or reply directly in the chat, so we can move to the next speaker. So we hopefully finish
Sure.
on time.
Okay.
Yes.
I try to answer them in the chat.
Yes. Thanks, Frank. So our next speaker is Angela. So I haven't met Angela before, but I'm very interested to learn more about what she does at Deliveroo. So I'm gonna read a brief biography for Angela. Angela, if you want to maybe start sharing your presentation, if you're perfect. So Angela is a senior data scientist and she works at the Deliveroo advertising platform. She's responsible to drive consumer traffic to restaurants. She uses ads and she increases also consumer conversion using restaurant offers. Before Deliveroo, she has worked as a data scientist in consulting companies like Mango Solutions and Informa, and as a researcher as the Autonomous University of Barcelona. Okay, so Angela, thanks for presenting today, and the floor is yours.
Thank you, Ricardo. Can you hear me? Fabulous.
Yes.
We can, yes.
Exciting. Good evening, everyone. My name, as Ricardo said, is Angela Castillo-Gil, and I'm a senior data scientist at Deliveroo. And today I have the pleasure to speak to you about building marketplace products with good enough decisions. Let's begin. So today we're going to look at 4 sections. First, the challenge with building marketplace products. There's 2 components to that, interconnectedness and then the cost of delay. Second, we're going to have a quick look at online advertising, and I'm going to explain why in a moment. Then we're going to look at rules for how to make good enough decisions. Then we're going to wrap it all up and apply what we learned today to a case study for determining the minimum bid for an advertising platform. So the challenge with building marketplace products. For those of you that don't know, Deliveroo is a three-sided marketplace with consumers, riders, and restaurants. We have to balance those three actors to drive a net profit for the business. Building a marketplace product is challenging because every decision has the potential to impact all three actors and the business. Imagine that we want to introduce a change to the consumer app. When we go and introduce that change, we might potentially affect all sides of the marketplace. And so in a marketplace, all three actors and the business are interconnected. So a single decision might impact all actors. Because of this, we have to think very carefully about what we choose to do. On top of that, we have the cost of delay, which is always looming, and there are strong incentives to launch sooner. Let me give you an example. Today, we're going to launch a product. And so for the first week that the product is live, we're going to generate X amount of revenue. During week 2, we're going to generate X amount of revenue, and so on and so forth. However, consider a product delay. For whatever reason, the product launch is now delayed 2 weeks. The revenue that we would have generated in week 1 and 2 becomes the cost of delay. To build marketplace products, we not only have to make decisions that are net positive to the marketplace, but time is of the essence. We want to minimize this cost of delay. I'd also like to mention that we are in a very competitive industry. We need to move quickly, and shipping fast is one of our requirements. I've introduced 2 concepts: the interconnectedness of marketplaces and the cost of delay. I want you to put that aside for a moment, and so that everyone is on the same page for what is coming up in the presentation, I'm going to give you an intro to online advertising. A very short introduction. We start with this premise. Every pixel on your screen is valuable real estate, and the pixels that you see most often are worth the most. So in this image, the top banner, the yellow, is the highest value because we assume that you as the user see it most often. The teal banner is mid-value because we are saying that you see it more than the red banner, but less than the high value banner, the yellow one. And then the bottom banner, the red one, is the low value section because you see it the least. Imagine that you are an advertiser. You want to appear in the top spot so that everyone sees you. So you go ahead and you bid an amount X. Given that the pixels on your screen are limited and there are several advertisers who would like to be seen by you, your pixels are auctioned. So now we're going to have a series of advertisers, everyone coming in, everyone wants to be on that top spot, everyone bidding different amounts. Advertiser B comes in and bids an X amount as well, which is less than the amount for advertiser A. And finally, we have an advertiser C that comes in, also wants to appear in the top spot, but bids an amount X lower than B. The auction happens in real time. Every single time you load a screen, every single time you search for something, every single time that you use an app that has ads, an auction, a real life auction happens. As an advertiser, I am willing to bid a higher value to occupy the most valuable pixels and have a higher chance of you seeing my advert. And these are the results of the auction. Advertiser A bid the most and so is in the high value spot. Advertiser B bid the mid bid and so is in the middle section, and advertiser C will appear in the red section because they bid the least. Here I'm going to introduce two concepts that we will use in the case study that will follow. First, the bid. What is the bid? Maybe you've already inferred this from the example. Bid is defined as the amount the advertiser offered to pay for each cost per click in order to appear in a more visible position. What is that cost per click? I haven't spoken about that. The cost of click is a pricing method in online advertising that means the advertiser pays for each click on their advert. These two concepts are important for the case study that we will solve together. Imagine that you are me and you have my job and you are building an advertising platform. Instead of general advertisers, we're going to have restaurants creating ads. And so you are tasked with deciding the minimum value that a restaurant can bid for their advert. Launch day is soon approaching and we need to quickly make a good enough decision so that we minimize the cost of delay. Notice that we have that time pressure, but we have to make a good enough decision. This gray bar that I have in the middle is a slider. So imagine it's a slider. And the section on the left is the minimum bid, the minimum amount that as an advertiser, a restaurant in this case, will be able to bid. Coming up with that number is our job. What do we do? Here's how we come up with that number. We make a good enough decision. I've decided to talk about this concept, good enough decision, because when we are shipping products really quickly, we don't have time to make the best decision. The best decision requires time. The best decision requires 2 weeks of careful analysis. We don't have that time because 2 weeks could be a huge amount in terms of cost of delay. And so that's where this term, good enough decisions, comes from. How do we do that? Simple. We build frameworks that allow us to quickly make good enough decisions. And at the most simple, a framework is a rule. If this, then that. If we move lever A by X percentage, then that's related to X percentage change in metric Y. Let me give you a specific example. Imagine that lever A is a delivery fee, right, for Deliveroo. What would happen if we increase the delivery fee for consumers? You can imagine that the number of orders placed by consumers would go down as we increase the delivery fee. And so we're mapping that relationship, this, if this, then that. Building frameworks means mapping out the relationship between levers and key business metrics. However, at Deliveroo, we live in a marketplace world. So we have to do this for every actor in the marketplace. Here on the left, we see riders. And so we have to consider what would happen if we move lever A by X percentage to a certain rider metric. What in the middle? What would happen to a restaurant metric if we move that lever A by a certain percentage? And finally, to consumer metrics, what would happen if we move that lever A by a certain percentage? The more relationships we map, the more likely we are to make a good enough decision under pressure, because we have done the bulk of the thinking up front. And in practice, how this works at Deliveroo is that we have dashboards built by the data science team, and those dashboards are used by any stakeholder in the business to self-serve metrics and to map out these relationships. So when crunch time comes, everyone has the analytics they need to make good enough decisions. Let's review what we've seen so far. First, marketplace products are complex. We saw that they are highly interconnected and the cost of delay is always looming, which is the second concept that we saw. Time is money, essentially. And now, thirdly, we've seen that using frameworks, we can make quick calls. We can make those good enough decisions. Now it's time for us to put it all together and to determine the minimum bid for an advertising platform. Let's recap again and review the case study. Imagine that you were tasked with deciding the minimum value that a restaurant can bid for their advert. Launch date is soon approaching, and we need to quickly make a good enough decision so that we minimize the cost of delay. So we're coming up with that minimum bid. Step number 1, how do we go about solving this? As we saw, the first step in a marketplace is to identify which actors are impacted by a decision. And the first actor that I identified was the business. You can imagine that as you increase the minimum bid, you also increase revenue for the business. Then I also identified restaurants, because as if we're creating an advertising platform for restaurants, and restaurants are our advertisers, as we increase the minimum bid, we start to make the tool, the advertising platform, too expensive for restaurants to use. So the higher the minimum bid, the fewer restaurants can use the tool. So we start mapping out those relationships. That's the second step. As I just said, as we increase the minimum bid, we increase ad revenue for the business. And how does that relationship look for restaurants? Well, as we increase the minimum bid, we decrease the number of restaurants that can use the tool. Finally, time for the decision. What do we choose? Step 3, we pick the value for the minimum bid that helps us hit our advertising revenue targets, yet allows the most restaurants to have access to the tool. So that's the number that we ended up choosing. And that's why the number that allows the most restaurants to have access to the tool, yet allows us to also hit our revenue targets. And with that, let me summarize. By building frameworks and doing the thinking up front, we can quickly make good enough decisions that build successful products and drive revenue. And just like Eduardo mentioned today, we are hiring as well. So feel free to email me at angela.castillogill@deliveroo.co.uk. Thank you.
Thank you a lot, Angela.
Thanks, Angela. So it was very interesting also to see the trade-off between accessibility and meeting the revenue target. I don't know if anyone has any question for Angela. There's a question in the chat, Angela. I don't know if you can see it.
Yes, this all works assuming there's enough demand for ads. And this is a general example. Yes. Did I answer the question? Maybe the person RN can be more specific.
Excellent. So thanks again, Angela. Thanks for your presentation. Oh, there is another question. So.
So Lucas is asking, how do you arrive at the optimal cost of an ad to maximize restaurant demand? Do you mean with cost of an ad the bid that a restaurant can put through, or specifically with the cost, what do you mean? The cost per click? Cost to the restaurant? Yeah, so that's a great question. That's a like supply and demand question. If we build a tool, a product that is expensive for the restaurant, they will understand that it is not financially viable for them to use this tool. Using analytics, yes. So we've currently launched this platform in Italy and the UAE, and we've been learning about about how restaurants are reacting to this advertising tool, because it's new for the entire platform. And so currently we are understanding which restaurants are using the tool, how much are they bidding, what are their budgets, and based on that, we are going to refine and improve the product. Does safety, so Julia Fernandez is asking, does safety of the delivery person feature in your model, or is it purely optimized for revenue? So presumably, can you be more specific, Kieran? Okay, so I think Kieran is talking about the another part of the business, which is the delivery part. I'm not part of that side of the business, Kieran, and so I'm not entirely qualified to answer your questions on that. But I think that reaching out to the Deliveroo Twitter might be more suitable for questions that are related to the delivery part of the business.
Okay, so thanks again, Angela, and we have a few remarks from Matthew about the next events of the Analytics Network before we close for today.
Yeah, thanks very much, Ricardo. And just a couple of points, because I appreciate that it is getting short of time, and also certainly Angela's talk has made me think about time I phoned up Deliveroo and got some food in place. So this event, obviously hosted by the Durham University, but also run in conjunction with the Analytics Network. And just to say, we are part of the Operational Research Society, and you can find details of that. So in a very similar way to what Durham University Analytics event has been doing today, it's very much around people sharing ideas, presenting ideas around the whole area of analytics. So we have a few events coming up. We've just actually recently had last month our Analytics Summit, which is a full day of analytics events. But you can see on the screen there some of the events which are coming up. But you know, a notice to everybody on the call, we plan these events with Durham University, with other organisations, sometimes run them entirely ourselves. We're always interested in people who want to participate and who want to potentially speak at one of our events. So you can see the details on there. You will get a copy of these slides afterwards.
Matthew, can you show the slide? It's not showing, sorry.
Oh, apologies.
The previous one, yeah.
Okay, so yeah, just thank you, Eduardo, for pointing that out. Yeah, just if you're interested to be a speaker at one of our future events or to get involved in the network in any way, you know, there is the website there. You will get copies of these slides. You know, we'd be delighted to get you involved. And with that, thank you very much, and back to Ricardo.
Can you show just quickly the events coming up? Sorry, just for a second, just for people to be aware of the previous one. Yeah. Yeah, that one. Yeah, there are 3 events coming up. And that's there is one tomorrow, in fact. Thank you.
Thanks, Matthew and Eduardo. And I think we're pretty much ready to close. So I would like to thank the OR Society, Matthew and Eduardo. I would also like to thank our student group, Rowan, Angus, and Diara for participating in this, and all our speakers that have been fantastic, and all of you as attendees. I hope you enjoyed the presentations, and we will send messages through Eventbrite, so with the details where you can access the video recording. Okay, so thanks again for attending.
Thank you a lot, and hopefully see you in a future event and also in another session with the Durham University.
Excellent. Yes, it was always great to work with you, Eduardo.
Thank you, Matthew, as well, for your support on the Zoom. And thank you, Angela.
Pleasure.
And
Thank
Frank.
you.